you come here, the important thing is more imperfect the mating surfaces, the more critical is the function of the gasket. Perfect surfaces are expensive. The final solution is a compromise between economics and performance. The important property that makes a conductive elastomer gasket. Instead of saying it is a polymer, and the word even elastic also has a little problem, because in intuitive understanding elastic is some rubbery material which is used for various places, and an elastic in engineering design means something which, when you remove the strain, when you remove the stress, it will come back to the original point. So it looks very counterintuitive, but if you take a rubber ball and try to bounce it off a rubber flexible surface, chances are it won't bounce at all. But then otherwise, if you take a very hard steel surface and then put a very hard steel ball, it bounces, because it is a perfectly elastic medium. Contrary to, as you said, no, that rubber band elastic has natural damping. So we have a little issue. I will skip it. Now coming back to this thing, to the, in the case of our electronics, we need to have good electrical as well as seal against the dust and other things. In practice, it has been found that the surface conductivity of both the gasket and the mating surface is single most important property that makes the gasketed seam effective. Once again, we need to go about working about simple flange materials. Flanges are made of the same material as the basic enclosure, and this is where I am sure at least some of you have faced it. You have seen that. This is what I was talking to you yesterday. It is advisable to add caution notes on drawings not to paint the flange mating surfaces. So when I showed you that power control panel and which had a earthing, I hope you are able to recollect that power control panel which had the earthing yesterday. If somebody were to paint before assembly, we have a unspecified contact. So some conditions it will more by accident it will continue, otherwise it will not continue. This continues to happen. Normal places probably it is not very critical, but in some places it becomes. You have seen that if the assembled units are subject to painting or repainting in the field, cautionary note in a conspicuous location adjacent the seal, that the seal are to be masked before painting. Once again I will take you back to the street light controller there. There it is not so much about EMI or EMC, so as such we can get away with it, but imagine somebody has to mount a wireless sensors inside such things. We have done that also in the very earliest first lecture. I showed you some soil moisture sensors forming an ad hoc network and all that. So there we try to use you have seen this very important thing. Gold, why we continue to plate things with gold is it does not get oxidized in the normal anywhere, no, it's in a very beautiful base condition, it's a noble material. However, in contrast, silver oxidizes easily in the atmosphere. If you were to etch silver and leave it in the environment, very quickly it will turn black, including all those connectors and all that which are silver plated, it forms a black oxide. However, it is relatively conductive. It does not matter, you take out the, if it is have an N type connector, you can unmate it and then you mate it, and if it were to be, it is very rarely it is silver plated or come with nickel for some other reason. So, if we were to take any BNC connector or anything which are, gold is very expensive, only in very low, I mean very high frequency small sizes they use gold, as in SMC and all SMA connectors. Alternatively, BNC is usually silver plated. So, if it turns black except that it looks unsightly, you can continue to use it without any risk of anything. You see here at the most oxides are hard. Oxide layers remain thin, other build up to substantial thickness in a short time. Effect can be overcome to a degree by using materials that do not oxidize readily, or by coating the surface with a conductive material that is less subject to oxidation. So, I will now move on to a grooved design. Oh, we have an important thing here. If you leave any compressible material, you have seen that nicely they have got anything called compression set if over compressed. So, this is where I was trying to point out to you that the normal rubber or the elastic rubber bands we see around used with apparel, for a starting with the natural size, the amount of strain it can take can be, if the natural size is let us say 100 millimeters, easily you can stretch it up to 300 millimeters. For a few operations it will come back to that original 100 millimeters. So, strain can be 300%, 200 to 300%. However, a truly elastic thing like steel, strain will be usually single digit percentages. So, this is where the little issue comes. What looks counterintuitive, not all elastomers will come back fully to the shape which we have started with. So, we have here, because flange surfaces cannot be held uniformly flat when the bolts are tightened, gaskets tend to over compress in the area of the bolts. Proper groove design is required to avoid this problem of over compression. Groove provides metal to metal contact between the flange members, reducing contact resistance. Single groove will suffice for most designs. Adding a second groove parallel to the first will further reduce all the radiation by 6 dB, which is a lot of problems and advantages. You see here, most designers fight a space limitation, saying a maximum amount of space we want is inside the enclosure, and then similarly outside we need to stack them close together. So, there does not seem to be enough space for really gasketing the design properly. This is the very reason you have seen this, we want to stack them close to each other, and then inside we need to have the maximum amount of space. So, walls we are able to manage, but when we come to the seam, when we want to do the cover, we end up with the invariable problem of, we have a flange here and then these are all extra space unnecessarily. So, what they do is people try to make the basic enclosure, that is what those pictures I have shown earlier, and all around wherever the fasteners are there, depending on the oh, I had closed the tab, I think it is fine. They try to make sure that you try to put up with the minimum amount of flange that is required for two things. One is both the surfaces to make in contact, and only around the screw head or around the bolt where you try to apply, they try to provide a small circular flange, and inside generally are maintained flush and clean such that you can do various types of operations inside, especially stacking things and then making sure of various things. So, it is occasionally the mounting screw, in fact if it is in the corners there is no problem, but anywhere else you end up with a small circular thing inside the equipment, wall, two projections, corners, and then we have the nice design for the gasketed thing. Let me go a little faster. You have seen that ideal flange includes a groove for limiting the deflection of a gasket. The screw or bolt fasteners are mounted outboard of the gasket to eliminate need for providing under the fasteners. A machine flange and its recommended groove dimensions are shown. So, this is the important thing I thought you must see. I am as happy as you that I have finally come here. So, this is directly taken from probably practice that is done in the what do you call chemical industry, but is equally valid for us. If you can somehow make sure that these two mate together, this gasket is only for other applications. So, we have various operations including what is the diameter of the washer here and groove depth. Slowly we try to extend it to cabinets. See this here, there is a very interesting thing. When you start, it is a nice beautiful circular pipe like thing. It is actually a round circular pipe. Once you compress it, two things happen. These two flanges meet. You have seen this, no? And then this fills the space properly. This is where probably that little lubricant helps in seeing that it sits comfortably here. And one side, you have seen this here, this prevents that this being compressing and killing the whole thing properly. So, this whole structure, this, all this is part of one of the faces. The top part is the other cover, and this can also be part of the cover also. So, depending on this, you have beautiful options here. So, this particular note is not only about all those how to tell almost magic like getting all those numbers and nomograms and all that. It is a lot to do with the detailing that has to be done here. So, if you go here, this is what I try to show you in the workshop. This is a properly done correct way of making things. You understood, inside there is nothing, and then the top cover probably starts here, goes up and then comes here, and inside this you can have the cavity for the gasket. Alternatively, the top cover can be flush also like this, flat, just covering this, and inside for alignment on this side there may be one more small guiding plate. Moment you make it like this, we can be very sure and absolutely no problem. Yeah. So, we have this various types of formation of the gasket. You have seen this, no? The sheet metal itself has these openings, sometimes the gaskets have all these openings, and the thing is all around the mounting screws they have to fit together. This is directly taken from the earliest probably automobile designs. If you take your, especially if you have a bike and if you take your that cylinder mechanism and all and the crankcase at the bottom, usually it is made in 3 parts. You have the center that part which takes the what do you call crankshaft and all that, that itself is either to one side or in the middle you have a nice cut and then you have a beautiful gasket material. In that case, because they are all machined and probably lapped and joined together, they apply a little bit of an adhesive shellac and then they use a special gasket paper. It is a thin cardboard, probably it is around 1 millimeter or so. After you apply the correct sequence of tightening, that is from the center to outside, that squeezes itself and it can withstand the heat and the oil and you can say until you next hit a rock. In our case we hit potholes and rocks, it just stays, nothing leaks. So, we have as we go down, we have corrosion which is real. Most electronic packages must be designed one of 4 general environments. One is class A, controlled environment, temperature and humidity are controlled, indoor habitable exposure. So, that is how we are able to get away with all that equipment which is very sophisticated. Actually, the way you are getting your internet connection is probably you have a beautiful server room and then there are server racks which also follow the 19-inch rack standards, and then you have so many switches and I do not know bandwidth managers and I do not even know the words, and then some cable comes and then what you see outside are only bunches of cables. And the beauty is the whole environment is controlled closely. 2 things are controlled. One is temperature, we know how to control, there is no problem. Stick up an AC on all the walls, or if you like us, if you have a cassette air conditioner somewhere in the middle. But you have another serious issue about it, that is the moment you chill any air, condensation takes place. So, how do you get rid of the water? It looks somewhat sometimes tricky. If you have to take a cool drink or a water bottle and you keep it outside, you will notice that condensate forms on the outside. And in contrast, let us say you take your cup of tea or coffee and you put a coaster or a cap on that, you will see that condensation takes place, and then when you lift the coffee you will see a patch on the ground. Nothing, there is no great anything, I am sure you have figured it out. Allow me to point out the condensation takes place on the cooler surface. So, if it is warm and it is saturated, the moment it comes it goes and condenses on the cooler surface. So, now take the example of a server rack or somewhere where we assume we started with reasonably dry air. When I talk about dry air, I feel RH should be around 20%. But then as you cool it, you will see that the humidity goes up, amount of humidity. And if you are one of those unfortunate, I won't say unfortunate, one of those what you call people who have to live in a environment which is to start with has high humidity, you already start with 80% RH. So, the moment you cool it, you end up with condensate everywhere. So, imagine one surface in that whole room faces this cold what do you call, cold blast from the AC. While it looks fine, the other surface, by some bad luck for us, let us say there is a warmer what do you call, zone inside which is also saturated. First thing you will notice is condensation starts on the inside of the cabinet. So, in a truly controlled environment, what is done is special dehumidification action is taken. The simplest way to dehumidify is probably chill the air until it loses all the heat. Until it loses more heat than it is carrying. The moment that heat is carried away, condensation takes place, and make sure that all is done outside the zone which is in control. So, all the water is taken away. Instantly you can use that water back. If you can clean the whole thing and put it in a bucket, best way is you can use it in the UPS batteries. Sorry for this little side thing. So, you see, the moment that highly chilled air, normal ACs and all, they usually the outlets adjust to around 12 degrees. It is not a very bad thing. Let us say you are able to get all the thing out to say 3 or 4 degrees centigrade, a lot of the water will get out. Then inside the ducts which are used for it, heaters are used to bring it back to the ambient which you will enjoy, which may be around 24, 22, 23, 24 degrees ambient. So, two things happen, the air becomes drier, the air is at the temperature you want. So, probably I am coming to the a little towards the end of my time, but I would like to point out, do you remember the old refrigerators had used the word Frigidaire, or just something which was done maybe around 20 years back. They used to have that black wires at the back, tubes. You do not find them anymore. And a funny word called direct cool also is used. I do not know what is direct and what is indirect cool. So, you see there that device you see at the back which is outside the refrigerator is a condenser. So, all the evaporated refrigerant comes there, it loses heat to the ambient, and after it loses heat to the ambient, which is let us say if the ambient is at 35 degrees. So, easily up to around 40 degrees that thing, about 5 degrees is sufficient for it to lose the heat by natural convection. And then that is when it is again pumped inside the compressor, and then when it evaporates you can get any temperature you like inside. But suddenly around 20 years back things have changed, you do not see that black snaky coil at the back. So, what happened? Think about it. And then you also find a sticker on the side of the refrigerator, on the side there is a sticker. You will feel this warm, that is natural, do not panic. If it is a salesman who is going to tell you, I will panic, saying this is what you told me last time when you sold me the fridge, saying the condenser and the evaporator should be isolated. But now you are saying no, by some magic we have pushed it inside the things, which is just the opposite. Same salesman who sold us a window AC said, sir, because of the system complexity, both of them we have put them together, you should not isolate them. You understand, they have put everything in a box and then made a hole in the wall and then pushed it into the box. That same person tells me, no, this is not a very good thing, because making a big hole is adding some problems. So, we now made a split AC, which a refrigerator was a split thing earlier. We had the condenser inside and the evaporator inside and the condenser outside, and suddenly now everything is in one box. So, now you think about it, it is not just a technical issue, not just a technical issue. The issue is it prepackaged and is the technique possible for you? Right now in the case of refrigerators and all that, they have found out that you need to warm the enclosure, else condensation takes place somewhere. Inner surface is cold and then you have the metallic wall, you have of course cladding or other thing, but still the inner surface is cold. So, it is not a very sealed or hermetically sealed enclosure. chances are the moisture keeps getting there inside. As it goes down, it will start corroding the surfaces at the bottom. So, they have found out an obvious easier way, saying why do not you warm it up, which is done in the case of marine equipment. In the case of marine equipment, there are heaters which are fitted along with the cabinets. Duct heaters are one thing, other bay heaters are there. The bay heaters are put such that the whole thing is maintained at a slightly higher temperature than the ambient, because in the marine atmosphere, however hard you try to get rid of water inside, still there too much of it. It is not just in the bilge, even all the rooms everywhere you need it, but you can't sit inside a ship all the time. Sometime you have to come out and see where you are going. So, there in the case of marine atmosphere, they take tremendous thing by using both bay heaters as well as duct heaters to ensure that the humidity is under control. So, you see here in the case of a uncontrolled environment, humidity are not controlled, exposed to 100% with occasional wetting. You have seen this. Outdoor exposure in uncontrolled warehouses. Warehouse need not be very, what do you call, not all the warehouses are controlled carefully. So, added to that, now everything has to cross some sea or the other. Mostly it has to cross the Atlantic and go to the other side, or alternately it has to come through probably our Mediterranean and then it has to come there. So, you have two things, already all the containers and all that probably are full of moisture. Now, you bring all the equipment and put them inside. Now, you know how tough it is to install them inside. You see here shipboard exposure or land exposure within 2 miles of salt water where conditions of class A are not met. This happens all the time. Right now things have changed considerably on the better side for it. Not very long ago, about 40 years back, most ceiling fans, table fans had blades. Ceiling fan, there is a table fan, had those blades made out of mild steel. And even now occasionally things like exhaust fans for various I do not know, some considerations that try to use those otherwise corrodable materials. First thing you see, that leading edge starts gathering dust, and the moment you have dust, a little bit of fungus forms, and then fungus forms, fungus also grows nicely in the wet environment, and the leading edge slowly becomes thicker. So, in trying to dust, what will you do? You probably take a cloth and you try to clean it. And then after 2 or 3 cycles, you will notice that you cut your finger because it has become like a knife edge, because all the rust that has formed there is spoiling the whole thing. It spoils the environment, the flow of the air. So, if you carefully take enough care, they still maintain those things. But we have got over that on 2 things. Small things like these table fans and all, invariably the blades are made with some polymer plastic, depending on what you want. Probably the most commonly used is ABS. Occasionally you find polycarbonate, and they are made transparent. I have even seen things which are made with transparent PVC with soft blades. So, accidentally if you touch it, maximum you get a slap on the wrist, nothing beyond that. But mind you, do not try it, do not put it, because they are very sharp. So, you see that those things have now been replaced with 2 things. One is ceiling fans are replaced with aluminum blades, and then the table fans are all replaced with other non-metallic materials, so that rusting does not take place. So, it happens here that any of you who live in the exposure, area where humidity is very high, you end up with this unwanted salinity in the atmosphere. Okay. So, there is a huge table here. Probably after this I will give it a break. You see here metals, carbon alloy, steel, aluminum, so on and no, copper clad, magnesium, zinc based finishes, no, class A, B. We are slowly coming into something here. Have you seen this? Probably it is old. Cadmium is banned now. We have a serious issue. Cadmium is environmentally unsafe, except where you cannot, for various reasons. One of the reasons being the other mating surfaces are already come with cadmium. So, you cannot put a nickel plated cover with a cadmium plated this thing, because it makes a perfect 1.2 volt nickel cadmium cell. Good, no? Nickel cadmium is 1.2 volts, or I do not know, maybe 1.25 or so. The electrochemical equivalents of them, no, they make that. So, you cannot, suppose the other part already comes with a cadmium plated, you cannot replace it with anything, you are forced to use cadmium again. Otherwise, by default everything is zinc with passivated with bichromate. This anti-corrosive steels, no finish is required, absolutely. And you see this beautiful, this thing, chromate conversion coating is done. That is, I am not very familiar with the process, except that you need to specify either zinc or basic aluminum itself, you can do this chromate conversion. And aluminum 3000, 6000, 5000, all these are new modern materials with silicon, probably elements, I do not know, traces of copper, and very, very complex metallurgy. So, this complex metallurgy, you would have come across 6065 bicycle tubes and also 707 something. So, we have 60005 and then 70, I think 65 and so on of these things. They are all incidentally, luckily for us, they also do not need conductivity. As you hear, no, 6000 series, no finish is required unless shielding requirements are high. Otherwise, no, by default everything is given to a chromate conversion. That is, it is heated, cleaned, surface is activated, descaled and dipped in a chromating bath, potassium bichromate. Further down, everything else by definition is tin plated. Advantage of tin plating is, first of all, it is slight bluish luster is there, shines, looks a little like chrome. So, in fact, several of the kitchen appliances, you see all those metallic things, either they are fully stainless steel, or if not, it is zinc plated, it is harmless. I am sorry, tin or zinc, one of those things, tin or zinc plated, very rarely you find nickel in that. So, the advantage for it is zinc can also be chromated. Tin, bright tin is absolutely no issue, except when you are trying to use your remote control for the AC or for your TV or I do not know, for switching me off. The battery contacts usually they come, for some reason they come with nickel plating, not tin plating, and then the wire which is connected to that is soldered, and then something, that spring which comes on top of it. The platings are not easily compatible with that cell which you use, that cell which you put inside. They recommend that we put alkaline cells. Some reason something happens and it forms a loose contact. All you have to do is take it and rub the cell, and also try to clear the compartment. You put it back, it seems to work. I am just trying to give you a common example, and then I think before you switch me off, I will stop. We will continue next time. So, thanks for listening to this.